At 06:15 hours local time, soldiers from the Security Service of Ukraine, the SBU, began what appeared to be a routine attack mission. But within only a few minutes, everything would explode, quite literally. Their Shark-D reconnaissance UAV was flying along the highway of death at Novorodivka, searching for a suitable ambush position. About 14 miles ahead of the convoy, the road passed through a completely exposed area. There, infantry and mechanized vehicles could hardly move during daylight without being detected. A perfect attack point. Below, the Russian convoy consisted of BMP infantry fighting vehicles, military vehicles, and trucks carrying weapons and ammunition toward the front line as reinforcements. It sounded simple, did it not? But what Ukraine did not know was that at that moment they had gone from hunters to the hunted. Each time the reconnaissance UAV transmitted images back to its operator, in theory it was also broadcasting a message into Russia's electromagnetic spectrum. I just transmitted data. And the Russians were using their most advanced technology to listen. The Russian military convoy continued moving at 35 miles per hour. On both sides of the road were artificial terracon slag heaps forming terrain walls that effectively concealed and camouflaged the formation. The Ukrainian strike team was only 8 miles from the target. But between them and the convoy were 5 layers of modern defenses positioned along the road and moving with the escort formation. Similar systems had previously intercepted more than 550 Ukrainian UAVs across the battlefield. The system you see here is the Svet-KU, a passive electronic reconnaissance system. It does not need to emit any radar pulses to hunt drones. It simply listens quietly. The Russians positioned multiple receiving stations throughout the area. Each time, the Ukrainian control crew transmitted a command to the Shark-D. The same radio signal reached the receiving stations at slightly different time. The difference lasted only a tiny fraction of a second, but the central computer could still measure it. Instead of drawing bearing lines that intersected at a single point, the system calculated the areas where the source of the transmission was likely hiding. Each time the Ukrainian crew transmitted more data, the suspected area continued to shrink. After several transmissions, their position could be narrowed to an area small enough for the coordinates to be sent directly to Russian artillery. There was no need to see the operators, no need for a reconnaissance UAV to confirm them. It only needed to detect the signal, calculate the location, and open fire. 3 minutes later, artillery shells could land directly in the area that had just transmitted. The Ukrainian soldiers understood this very clearly. Therefore, they did not give the Svet-KU enough time to complete its calculation. The Shark-D control system continuously switched between 128 frequency channels every second. Each transmission lasted only about 0.3 seconds, just long enough to send one command packet. After that, the entire system remained silent for 33 seconds. The Russian receiving stations could still detect part of the signal. But just as the computer began narrowing the suspected area, the signal disappeared or switched to an entirely different frequency. Each transmission was too brief and too fragmented to produce a stable location fix. The Svet-KU knew that a Ukrainian control crew was operating in the area, but it could not determine exactly where they were. Without sufficiently accurate coordinates, Russian artillery could not open fire. The Shark-D remained under control and continued tracking the convoy as it advanced toward the open terrain ahead. The Ukrainian strike team still retained the element of surprise. The target had not yet been hit, but the first decisive battle had already taken place, and Ukraine had won it in the electromagnetic spectrum. But then the situation became worse. The Ukrainian surveillance receiver detected a control signal from a Russian Supercam S-350 reconnaissance UAV appearing to the east. It was not simply passing through the area. It slowed down, banked, and began circling in an oval pattern. That meant the Russians had detected Ukrainian forces operating nearby. The EOLECH-IR sensor cluster beneath the UAV continuously rotated, scanning every embankment, tree line, and trench entrance with daylight cameras, thermal imaging, and high magnification. The Ukrainian team had concealed itself carefully, but the control computer's lithium batteries and signal amplifiers still emitted a small amount of heat. On the Supercam's thermal imaging screen, They could appear as bright points against the cold ground. The Russian UAV completed its first sweep, then it returned. The Ukrainian team had only one choice: continue tracking the convoy or disappear from both the thermal and electromagnetic spectrums. They chose to disappear. The commander immediately ordered absolute EMCON. Power to the video transmitter was cut. The amplifier was disconnected from the antenna. The computers and positioning equipment were simultaneously switched to standby mode. The batteries and electronic equipment were placed on thermal insulation mats. The entire team withdrew to the bottom of the trench, covered themselves with thermal camouflage netting, and remained motionless. Their position almost disappeared. But the reconnaissance screen also went black. Just before the link was cut, the system managed to save only the final coordinates, speed, and direction of movement of the Russian convoy. The problem was that the convoy continued advancing. With every passing second, the old coordinates became slightly more inaccurate. Without updated data, the strike team 3 miles away could fly toward a position that was already outdated. Direct radio communication was even more dangerous. The standard procedure required both teams to transmit signals to confirm, synchronize, and transfer data. With the supercam circling overhead, that would be like drawing a target over both positions. So they did something clever. Instead of sending one fixed coordinate, the computer used the final data to create an interception box, an area where the convoy was likely to appear during the next few minutes. The data packet included the convoy speed, the direction of the road, the terrain gradient, wind conditions, the approach corridor, and the estimated time when the target would pass the ambush point. The strike team did not need live imagery. They only needed to bring the UAVs into the correct area and confirm the target themselves during the final phase. But the reconnaissance team did not transmit the packet directly. A small relay UAV had already been positioned behind the tree line. The track file was loaded into it through a low-power one-way data pulse with no confirmation signal. After a short delay, the relay changed direction, entered the strike team's reception corridor, and retransmitted the data packet through a sequence of short bursts, too brief for the transmission source to be precisely located. No return signal to extend the exposure time. Meanwhile, the reconnaissance team remained motionless beneath the thermal insulation netting, while the Supercam S-350 continued circling directly overhead. The Ukrainian team could no longer see the convoy, but the strike team had received the data packet. 3 FPVs immediately entered the interception box, but they did not fly directly toward the final coordinates. The convoy was still moving, and the data would soon become useless. So the UAVs spread out in 3 different directions. They had to find the target again on their own. When they were only a few miles from the road, the map began to go haywire. The UAV icons jumped from side to side. Their speed and flight direction no longer matched the camera image. An R-330 Zytel system mounted on one of the Russian escort vehicles had begun operating. It did not cut the link, it did something more dangerous. It gave the UAVs a false map. According to the screen, the FPV was still flying inside the correct corridor, but the road ahead was gradually shifting in a different direction. The UAV was still functioning, but the operator no longer knew where it was. Then, one FPV reported a low battery and automatically began returning home. But because the coordinates of its launch point had been falsified, it immediately turned toward Russian-controlled territory. The operator shut down all satellite navigation. The other 2 UAVs did the same. From that moment, the digital map had no value. They switched to visual navigation. The final frames from the Shark D were placed beside the control screen. The Terracon slag heaps, power lines, ruined rooftops, and a bend in the road became their new landmarks. The UAVs were no longer flying by coordinates. They were flying from one terrain feature to another. But the Russians still had another defensive layer. One FPV in the formation suddenly climbed and reactivated its satellite navigation. Its signal immediately appeared on Russian surveillance equipment. It was a decoy. The Tor M2 system, accompanying the convoy, turned its radar toward the most visible target and opened fire. A few seconds later, the FPV disappeared from the screen. While the Tor M2 was looking upward, The other two descended close to the ground and followed the concealed side of the Terracon. No GPS, no continuous transmissions. The operators sent only brief commands, then allowed the UAVs to continue on inertia. The Svet-KU continued blanketing the entire area with interference, but it could not deceive a system that was no longer using satellite signals. The two FPVs crossed the final Terracon ridge, and the Russian Convoy appeared. It had moved nearly half a mile away from the predicted coordinates, but it was still inside the interception box. The camera identified the BMPs, ammunition trucks, and escort vehicles advancing toward the open ground. The operator did not enter coordinates. He locked onto the target directly through the video image. Russia had taken away the Ukrainian formation's satellite navigation capability. But it could not force every UAV to turn back. Ukraine lost one decoy. The two primary attack UAVs continued tracking the convoy. The second defensive layer had been breached. Navigation jamming was not the most dangerous threat. Ahead of the convoy, a system that required neither radar nor radio signals was waiting. And this time, electronic silence could not conceal the Ukrainian UAVs. After crossing the final Terracon ridge, the two Ukrainian FPVs were only about 1.5 miles from the Russian convoy. They had shut down GPS and the digital maps while reducing their control signals to the lowest possible level, transmitting only brief pulses when course corrections were needed. On the electromagnetic spectrum, they had almost disappeared. But the next defensive layer was not searching for radio waves. It was searching for shape, movement, and heat. From an elevated position beside the road, a Murom-P electro-optical station was scanning the area with daylight cameras, thermal imaging, and motion detection algorithms. No radar, no warning signal, it simply watched. When the first FPV crossed the open ground between two Terracon ridges, the heat from its 4 electric motors and lithium battery caused it to appear on the screen for several frames. The target was only 5 inches wide and flying close to the ground, but that was enough. The Murom-P marked the object advancing toward the convoy and transmitted it to an optical suppression device mounted on an escort vehicle. A low-power laser beam immediately swept across the UAV's camera. The Ukrainian operator's screen was covered by streaks of white light. The connection remained active, and the FPV continued receiving commands. But the center of the image was almost completely burned out. The two UAVs immediately separated. The first climbed another 15 feet and deliberately flew across the open ground. Its outline immediately became clearer on the daylight camera and thermal sensor. The Murom-P switched to tracking it. The laser beam also turned toward it. At first, this appeared to be a mistake, but it was a decoy. While the Russian system focused on the first UAV, the second FPV descended from about 20 feet to only 10 feet above the ground. Without GPS, it used optical flow to maintain its course. The system measured the movement of the terrain across each frame, allowing it to estimate speed and deviation. When the video was blinded for 3 seconds, the UAV maintained its last bank angle, speed, and heading. No image, only inertia. When the camera could see the ground again, the system immediately corrected its flight path. At that exact moment, the Russian convoy entered a section of dry dirt road. The BMPs, weighing tens of tons, crushed the surface beneath their tracks, while the trucks created a long cloud of dust behind the formation. The dust reduced contrast on the daylight camera. In the thermal image, hot engines, exhaust systems, the heat-absorbing road surface, and multiple vehicles moving close together created a chaotic background. The Murom-P lost its stable track. The laser beam slipped away from the camera. For several seconds, the second FPV's video returned completely. The operator saw the BMPs, escort vehicles, and the ammunition truck positioned in the middle of the formation. The target was only 0.5 miles away. But just as he began locking onto it, a black dot appeared above the convoy. A Russian interceptor UAV was diving toward him. The Murom-P had provided the initial bearing. The rest was being carried out using the interceptor UAV's own camera. It was flying at an altitude of about 75 feet, 50 feet above the Ukrainian FPV. In UAV combat, altitude is energy, and energy means options. The Russian UAV dived at a 50-degree angle like a hawk striking its prey. The two UAVs had nearly the same maximum speed, about 140 kilometers per hour, but the Russian UAV carried no warhead. It only needed to collide. That made it lighter, faster to accelerate, and capable of making tighter turns. The Ukrainian FPV, however, was carrying 5 pounds of explosives. In an aerial battle, that was like entering a fighting ring with a backpack full of rocks. Every turn was slower. Every climb consumed more battery power. Their combined closing speed was now nearly 240 feet per second. At a distance of 1,000 feet, the two UAVs could collide in less than 4 seconds. 4 seconds to detect, 4 seconds to react, and 4 seconds to choose between evading or continuing directly toward the ammunition truck. A delay of only half a second would end the entire mission. The Ukrainian FPV immediately dropped in altitude. The Russian interceptor UAV did not fly directly into the target. From a distance of nearly 300 feet, it approached from a 35-degree diagonal angle above and activated its net launching module. A net nearly 12 feet wide fitted with 4 small weights at the corners deployed in mid-air. It did not need to cover the entire UAV. If even one strand wrapped around a propeller spinning at more than 20,000 revolutions per minute, the Ukrainian FPV would immediately lose balance. But the Ukrainian operator reduced the throttle, descended from an altitude of 10 feet to about 4 feet, and flew directly into the dust cloud behind a BMP. In less than 1 second, the Russian UAV's camera lost the target. The net flew through the dust and passed about 6 feet above the FPV. The first shot missed. The Russians did not continue following directly behind. The optical computer aboard the interceptor UAV analyzed the target's flight direction, speed of 75 air miles per hour, and bank angle. From that information, it calculated where the Ukrainian FPV would appear 2.5 seconds later. Instead of pursuing it, the Russian UAV accelerated to the right and followed a 200-foot interception path. It was moving to an intercept point. If the calculation was correct, the Ukrainian FPV would fly directly into the second net launching corridor. The problem was that the FPV's flight controller was still trying to keep the aircraft stable close to the ground. That prevented it from crashing into the road, but it also made the flight path far too predictable. The Ukrainian operator switched to fully manual mode. He disabled the self-leveling function and reduced power to the 2 left motors to 30% for less than half a second, while the 2 right motors remained near maximum power. The FPV did not turn along a normal arc. It slid sideways. The nose remained pointed forward, but the entire airframe shifted 15 feet to the side in just over 1 second. The Russian computer had predicted a turn. It had not predicted a lateral slide. The interceptor UAV flew through the intercept point after the target had already moved nearly 20 feet outside the launch corridor. But the Ukrainian FPV also paid a price. The battery voltage fell from about 22.1 to 20.6 volts within several seconds. The camera shook violently, and the horizon tilted nearly 40 degrees before the controller restored stability. Every unbalanced change in motor power consumed energy several times faster than a normal turn. And the FPV still had nearly half a mile left to fly. The Russian UAV circled back from the rear left. The distance fell from 300 feet to less than 200 feet. At a closing speed of nearly 200 feet per second, the Ukrainian operator had only about 1 second before the opponent returned to launching range. He did not try to accelerate in a straight line. The FPV flew deeper into the dust created by the trucks and BMPs. Inside the dust cloud, the optical flow system began losing its reference points. No more rocks, no clearly visible tire tracks, only a brown screen shaking continuously. The operator was forced to maintain direction using images that appeared only in brief flashes. The edge of the road, utility poles, and the horizon above the convoy. The Russian UAV was 5 pounds lighter because it carried no warhead. Its better power-to-weight ratio allowed it to accelerate faster and continue closing the distance. Then, the Ukrainian FPV moved close behind a BMP. The vehicle, weighing more than 30 tons, was moving at nearly 35 miles per hour and creating a turbulent wake extending dozens of feet behind it. The FPV shook violently and was pushed to the left. The flight controller tried to correct it, but the Ukrainian operator did not resist completely. He reduced the throttle to 40% for nearly 1 second. The UAV allowed the airflow to carry it more than 10 feet away from the road center line. Then he applied maximum power. the FPV burst out of the dust in a direction completely different from the flight path the Russian system had been tracking. The interceptor UAV lost its optical lock for about 0.8 seconds. That interval was enough for the target to move nearly 80 feet. The Russian UAV quickly reacquired the FPV's outline. The net launching module had only one shot remaining. It approached from behind, descended to an altitude of less than 20 feet, and closed the distance to 60 feet. At that range, the net would take less than half a second to reach the target. The Russian operator fired, but at that exact moment, the Ukrainian FPV cut its throttle and plunged into a 4-foot deep drainage ditch beside the road. The net passed overhead. The weights became caught on electrical wires and low tree branches, pulling the entire net away from the target. The Russian UAV was forced to pull up under nearly 4 Gs to avoid crashing into the terrain. No nets remained. Now it had only one option: a direct collision. The interceptor UAV dived again from an altitude of 25 feet, but the Ukrainian FPV had entered the middle of the Russian vehicle formation, where the gaps between the BMPs and trucks were only 50 to 80 feet wide. The vehicles, dust clouds, and power lines continuously blocked the approach route. The Russian UAV dived from above, but the roof of a BMP suddenly filled its camera. The Russian operator pulled up. The UAV passed only a few feet from the target while losing nearly all of its accumulated speed and altitude. It needed at least 4 seconds to turn back, but the Ukrainian FPV did not give it that time. The UAV stabilized at an altitude of 6 feet, accelerated back above 70 miles per hour, and escaped from the dust cloud. Ahead, the ammunition truck was now clearly visible in the middle of the convoy. The entire interception lasted only about 17 seconds, but 17 seconds of evasive maneuvers had consumed nearly 1/4 of the remaining battery power. The voltage was still falling. The ammunition truck was only 1 mile away, and the FPV had only enough energy left for one final approach. The Ukrainian FPV now had only 10% battery power left. The voltage had dropped to 19.4 volts. Ahead, the Russian convoy had just cleared the final Tarakan Ridge and entered the open ground inside the interception box. No more slag hills, no more tree lines, nowhere left to hide. But at that exact moment, 8 Ukrainian FPVs appeared from both sides of the road converging around the convoy. The sound of electric motors filled the air. The Russian soldiers turned and saw black dots racing toward them against the open sky. At a distance of 600 feet, they no longer needed radar or thermal imaging. The naked eye was enough. The AK-74 rifles immediately opened fire. At a rate of 600 rounds per minute, they sent bursts of 5.45 mm ammunition cutting across the approach routes. On the opposite side of the convoy, several soldiers used Baikal MP-155 shotguns. The heaviest fire came from the BMPs. Their turrets rotated backward using 30 mm cannons and 7.62 mm PKTM machine guns to create a wall of fire behind the convoy. The 2 lead FPVs immediately climbed to an altitude of 30 feet to draw fire. The first UAV was hit in its motor assembly, lost thrust, and rolled into the roadside. The second entered the fragmentation zone of a 30 mm round and broke apart in midair. All of the Russian fire had been drawn upward. The next 2 FPVs immediately changed targets. The first crashed into the sighting system of a BMP. The second struck the sensor area of another vehicle, blinding both turrets for several seconds. The 4 remaining FPVs descended to an altitude of 6 feet and flew directly into the middle of the Russian formation. The 3 remaining strike FPVs split their targets. One locked onto the vehicle, carrying the Zytel system, striking between the generator and the amplifier, taking the jamming system silent. The second climbed and dived toward the command vehicle, destroying its communications compartment and stopping the convoy's lead command element. The final FPV, carrying only 3% battery power left, descended to an altitude of 3 feet and locked onto the lower section of the cargo compartment on the ammunition truck. The warhead pierced through the cargo floor and ignited the propellant charges. The secondary explosion shattered the truck, setting off chain detonations across the fuel truck and nearby vehicles. Less than 90 seconds later, 3 major fires were burning in the middle of the convoy. The entire convoy was stopped in the middle of open ground. Above them, the Shark D recorded at least 3 destroyed vehicles and several others damaged. In modern UAV warfare, a 7-inch FPV does not need to carry a large warhead. It only needs to strike the correct system at the correct moment,